For homework tonight, please complete page 4 and correct it with this caption. For your first problem, we're going to write the 5-number summary for each group of chimpanzees. And note, some of the numbers are going to be approximate. The minimum for the 8-year-old chimpanzees matches with this value right here, 75. The lower quartile, or Q1 value, is going to be right here around, let's say, 98. Median looks like it's a little higher than 105, so I'm going to say 106. Upper quartile, it's a little higher than 125, let's say 127. And the maximum up here, a bit less than 155, I'm going to say 152. Again, some of those numbers may be approximate. 10-year-old chimpanzees, the minimum is 95. Lower quartile looks like it's around, let's say, maybe 128. The median is almost halfway, so I'm going to say around 130. The upper quartile, or Q3, is higher than 135. Let's say 138. And lastly, the maximum looks like it's 155. Next, let's talk about writing 3 comparison statements for the box plots. So one way to compare them would be to look at the amount of variability. And for example, we could look at the ranges of the chimpanzees. So for example, the range for the 8-year-old chimps, I can see that they go from 75 to around 150. And so if I take 150 and I subtract 75, I would have a range of 75. The 10-year-old chimpanzees go from 95 to 155. So if I take 155 and I subtract 95, I get 60. So I may be noticing that the range of 10-year-old chimps, I'm going to say 10YO for year old, and chimps for chimpanzees, is less than the range of 8-year-old chimps. Right? So in other words, I'm saying that there's less variability in the 10-year-old chimps. Right? And maybe that makes sense to me because I'm thinking about how as animals get older, maybe they become a little bit more consistent in their weight. Now let's think about another way to compare them. So another piece you might notice here is the interquartile range. And so I can see these are my interquartile range. This is talking about the middle 50% of the values. And so I'm noticing that for 8-year-old chimps, that's pretty big. It looks like it's going from around 98 to maybe 128. So again, if I was to compare those, 128 minus 98, I would have 30 as my interquartile range here. And then below, I can see that I have a upper quartile value of maybe 137, 138, and lower might be like 128. So that looks like it's only around 10. So I'm noticing that the middle 50% of the values are much closer together with 10-year-old chimpanzees than with 8-year-old chimpanzees. So we're going to talk about how the interquartile range of 10-year-old chimps is less than the range, or sorry, the interquartile range of 8-year-old chimps. Again, that suggests to me that there's less variability among the 10-year-old chimps. They're more consistent. All right, let's do one more, and let's think this time about measures of center. So we've talked about variability, that's more about measures of spread. Now let's talk about measures of center. So one way to think about measures of center would be to look at the median. And so in this case, I may be noticing the median values are a little bit different. So I'm going to notice here the median of 10-year-old chimps, right, which I can see in this case is around maybe 130, maybe a little bit more than that, is greater than the median of the 8-year-old chimps. And you can see here that's around 105. Right, so the difference between those, right, or maybe let's say it's around 130 minus 105, that's 25 pounds of difference between those middle values, between those medians. So it's looking like the 10-year-old chimpanzees weigh on average, or on median in this case, typically more than an 8-year-old chimp. Now let's think about the mystery chimpanzees. So we have a data distribution here, and we are wondering if it is likely to be talking about 8-year-old chimpanzees or 10-year-old chimpanzees. So what we like to do is kind of compare them. Notice that they have the same scale here. Each one is going from 75 to 155. So I can see pretty closely what lines up with what. For example, I might want to compare the medians. So I'm looking here at the mystery chimpanzees. I see the medians around maybe 128. On the 8-year-old chimpanzees, the median is around 105. And the 10-year-old chimpanzees, I see a median that's around 130, for example. So based on the medians, I'm probably most likely to think that the mystery chimpanzees are 10 years old. But then I want to check with some other measures as well. So for example, I could compare the maximums. And here I see maximums are kind of in the 140, maybe 149, 150 range. The 10-year-olds go all the way up to 155. So that, just looking at that measure alone is probably not conclusive. But looking at the medians, for example, also looking at the minimums, I can see that the minimum for 8 years old is a lot lower than the mystery. I can just kind of compare and notice which distributions have more overlap. So ultimately, I'm probably most likely to say that the mystery chimpanzees are 10-year-olds because, right, the box plots have more overlap. So in other words, their measures of, or their 5-number summaries, for example, are more similar to each other. And hopefully as well, you can just notice kind of the size of the interquartile ranges are much more similar, right, between the mystery and the 10-year-old, right? We're looking at to see kind of, again, the amount of overlap that there is between the two to try to make a good judgment. That's it for homework today. We'll see you tomorrow.